In this lesson, we're going to be talking about systematic programming. Kind of it kind of comes from the name of the system that you want to take anytime that you're programming. You should have a certain kind of approach that you're always taking, and you should kind of be repeating every single time you program. What's helpful about doing this is this allows you to do your program and know where to look for certain things because you're following the same pattern time and time and time again. It also helps other people that know how you program. It helps them find the information that you're going to try and present to them. So, what systematic programming is organizing and documenting in your programs. It's how it's organized, how it's documented, so that then you're able to find things easily. And we really need to do this in order to help with any type of reading or debugging. Reading is just someone coming along and reading your code. And that sounds a little bit crazy that someone's going to come along and read your code, but it is definitely something that does happen, especially in the professional environment where they're going to have to go in and read. For those of you using the GitHub with this class, you will kind of start to recognize this of, hey, yeah, I need to be able to go in and look at some of their code, but also, and with that being able to see, hey, this is what's going on. Debugging is figuring out where your issues are. And so if you're able to kind of build everything in the same way, you can help find issues faster and make them so that they're better suited and kind of less likely to happen. And then whenever they do happen, more easy to find. You don't want to read 5,000 lines of code that's not really well organized, and so you won't be able to find your bug. Because yes, there are debuggers, but they're not always great on where the issue actually exists. What debugging is, for those of you not that don't know, it's the process of fixing any syntax or semantics or any kind of issue that happens in the program. The use of bugging is, I mean, you don't want bugs in your fruit, so you're trying to get the bugs out. You're trying to make it so that it runs smoothly and works well. So one major component of this is to be able to document what is happening so that you or someone else can understand how it operates and how it works. So in a nutshell, you're providing a manual or a blueprint or kind of like yeah, I guess manual is the best one of like, if you have a car, you have your car's manual that helps explain how it works and what you're doing with it. In a program organization, there should be three main parts. The first part is the initialization. This is everything that needs to be done at the start of the program. This can be backgrounds, it can be locations, it can be variables, it can be all of these different pieces. Think of if you go and play a game. Let's just use an arcade game that's in the middle of the mall or in the middle of the street or whatever. You go and play a game. You want to start from the beginning. You don't want to necessarily pick up where the last person played because you won't get that experience. And so that's what initialization is. It's saying, hey, we're going to start fresh. We're starting new. This is where you do all your declarations, and we'll talk more about those in a much later lesson. But this is where you kind of set everything up. After that, we have our main program, and that's kind of a kind of a misnomer in that you say, yeah, it's the main program, but really what this main program is going to be made up of a bunch of procedures and functions. So the main program calls on specific procedures and functions to happen. But a lot of times, especially in a lot bigger programs, you're going to have a lot of procedures and a lot of functions that happen over and over again. And so, what a procedure or a function is it's something that happens many times. It's something that you as a programmer are going to have the program do over and over and over and over again. Yeah, you can do something and code it again and again and again, but that's not necessarily helpful or something that you would want to do. There's an acronym in coding called DRY, that is DRY, D-R-Y, and it stands for don't repeat yourself. If you're repeating the same thing over and over again, you could probably automate it into a procedure or a function, or you maybe should kind of reevaluate how everything is working. So just kind of continue with this program documentation. Do you remember what you had for dinner 11 days ago? I know I don't. I barely remember what I had for breakfast today, let alone, what I had 11 days ago. Now, some of you might be like, oh yeah, I totally remember because it was my birthday. All right, sure. But do you know what your neighbor that wasn't there with you, what they had at their house 11 days ago? I most certainly do not. And so that's something that we got to kind of think about whenever we're talking about program documentation. Like, where are you going with this? Well, whenever we're talking about a program, it's something that you're doing personally. and or as a group. And when you're in the moment, it's really easy to follow along with what your program's doing and why it's doing it and all that type of stuff. But after a couple days, if you leave the program and then you come back to it, you start looking at it and you start going, what was I doing? Like, what is going on? And so that's why we use this thing called commenting. And so with using this commenting, we're able to document what's going on at certain points in our program. I mentioned this in a prior video, but we need to document with comments in order to provide kind of insight to what's going on in our program. And this helps when you're looking at your own code, especially a couple days or even months or even years in the future, or when someone else is looking at your code, potentially for the first time. They need to be able to understand what's going on in your program and why you made the decisions that you did, or why you used the values that you did. So comments are made to make your code more understandable. Um, this allows for, if you're making a change, let's say your equation was wrong, they can find that specific thought process, and they can help fix that issue. If the most common thing is you have a client that says, oh, I want blah blah blah, you're like, well, okay, normally we do it in red, I guess we're going to do it in blue. And so you have to know, where was red implemented so that we can change the colors. Whenever you're writing any code, you need to document it. And this is, I will admit, one of the hardest things to remember, because you're just in the middle of your like your coding session. You're like, yeah, I'm doing this, it's going great. And then at the end, whenever you get back to it, you go like, oh my gosh, I don't remember where this documentation needs to happen. Now, I'm not saying you have to do it like real time, but you should on occasion be providing comments. Why did you go to this procedure? Why did you go to this function? Which procedure does it use? What function does it use? What variable is it? So just kind of a general idea of what's happening. Whenever you're first getting started, though, I do recommend kind of just line by line providing the comments and just saying, hey, this is the comment that I'm going to do for each thing. This makes it red, this makes it blue, this makes it move, this makes it turn, all that type of stuff. So there's kind of two parts where we need to do comments. We need to do comments at the beginning, and then we also need to do comments as we go along. The beginning comments really is so that we can give credit to where credit is due. So you're going to put the name of the program, you're going to put the name of the programmer, yourself or myself if I'm the one that's writing the program, the date that you created it, so that then you can say, hey, yeah, there was a lot of patches that have come out since then, maybe something's changed, and what the program does. And this just provides everyone with a little kind of insight of like, this is the purpose of what's going on. And this should be at the beginning of every single piece of code that you're doing. So, program name for a lot of the things that we're going to do in class, I call it the unit dash the lesson, and then provide the lesson name. And so that way I have something that I can go back and I can look at and I can say, oh, it's for this, it's for this, it's for this. And it's also really important to kind of follow your file management to also provide that type of information. Other doc comments to include, you need to make sure that at least each section has comments in it saying, hey, this is what this is doing. Sometimes, especially like I said, whenever we're first getting started, I like to start with commenting everything. Variables. You need to kind of label variables, and variables should also be well named. We'll talk more about naming variable wells in a future lesson. And also any formulas or algorithms that need to be commented. Where did you get that specific math from? Like, why did you make that decision? What choices did you make? What variables did you use? So kind of what is it supposed to look like, so that then if there's a math issue, you can go and find that pretty easily. In order to make a comment on Scratch, what you want to do is you want to right click on the code block or in a blank area. And I think with Chromebooks, it's two-finger touch. If you don't have a mouse yet with your Chromebook, I would highly recommend getting one for this class. I know me, if you're taking the class with me, I do have mice available for you to grab. If you're taking with someone else, check with them on if they have mice available. So right click or two-finger touch, so anywhere on the main block coding area, and click add comments. And if you click, you can kind of see up here, this is me not clicking on a block. It doesn't have a line attached to it. If I right click on a block and click comment, there is a line that goes and attaches. This can help with, like, if you can imagine these were crossed over, you'd follow the orange and you'd follow the blue. You can get lost pretty easily. These little arrows right here will actually make it go up and down. For the most part, I always just leave them down. No reason to hide them. So in this one specifically, this is the warm-up 2.2. It was the butterfly. I'd put my name, I'd put the date, and I might say what the program's supposed to do. It's supposed to draw a butterfly. So the initialize screen, so it just sets everything up. It makes things hide. It goes to certain spots. It erases all, and it puts the pen down. And then this part right here is what draws the butterfly. Oh, I did lines with that. Forgot about that. Now, looks, we've used motion to make things kind of move. We can also use looks to make how the sprite actually looks. And this can change costume, it can change the backdrop, it can make the color change, it can set the color, it can clear graphic effects, it can make it like get all mixed together and stuff like that. And so there's a whole bunch of options inside of looks. So go ahead and, if you need to, pause this video as we're going through this and put down this code. So have it when a green flag is clicked, and you can just do a new set of code for this. Have your program move 10 steps, then switch costumes. And if you have Scratch, the cat selected for this, it works best. So move 10 steps, next costume, 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 move 10 steps, next costume. And so you're going to do that. So yep, switch, switch. And this will actually give it it should hopefully kind of give it a little bit of an animation appearance. Not great, it's a little, stuttery, but it works. And actually on this one, it will pretty much just teleport to the very end. And the reason why is we need to put some weights. So wait actually has it pause for a second. What's happening is it did run and it did do all of those pieces of code, but whenever it did it super fast. So what we're going to do is we're going to add in this weight, which can be found inside of, I think I put it, there we go. Nope. It's located inside of events or control, one of those two. So you can go and you can find the weight. And I think by default it says 1 second. That's really long, so change it to be that 0.2. You don't have to include the 0. You can if you want to. Now, doing this is great and all, but remember that acronym I told you? DRY, dry, don't repeat yourself? Well, whenever you find yourself starting to repeat yourself, means that you could probably be doing something with a loop. And so by doing something with a loop, it does it over and over again, either the number of times that you tell it to, or for a certain number of times, or forever. You can provide reasonings and abilities and like kind of logic on how many times it should run. These are all located under the control tab. So the first one that we have is the repeat, and we just tell it the number of times to repeat. Do this 10 times, do this 5 times, do it 16 times. Then we have the repeat forever. Well, this repeats forever. And one thing to kind of note with some of these blocks is you'll notice this set has the repeat 10. This is all the code that happens inside of it. This is what gets repeated 10 times. And then this is what happens once it leaves this repeat. This forever has this smooth bottom that indicates that nothing will ever happen after this forever loop. It'll just keep doing this forever loop, well, forever. This one down here, the repeats until a certain requirement is met, is kind of more logic based. So once we cross a certain threshold, we want it to stop. Or once it does something specific, we want it to stop. And you can see again, it has that little tab down here below that indicates it would continue on to the next thing. For this, it would go until as long as x is less than 0, it's going to keep doing this. So once x becomes equal to or greater than 0, it's going to stop. So what we're going to do, go ahead and try removing all of that code. Now, there's something that a lot of people struggle with is deleting code. It is okay to delete code, especially once you, like, a lot of times whenever I'm first coding, I'm going to code something and then it's going to, like, I'm going to be like, oh, I could have improved it this way. It's okay to delete code. If you really need to, you can go and save it in another spot and be like, just in case I need it, you already have it kind of pulled out. So what we can do is we can, instead of having it move 10 times next costume, wait, or I think we actually had it move 10 times, wait, next costume, something like that. We can actually set it and we can just have it happen 10 times. So that then it has all inside of this repeat, it's move 10 steps, next costume, wait, and it just repeats that 10 times. So the next thing we can also do is you can set the size, and this is inside of that look section. Um, and you can have it set the size to 100, and then whenever it does its little move system, have it change its size by 10. Now, one thing to notice in this is that it moves 10 steps, does the next costume, waits 0.2 seconds, then changes its size, and then it comes back up to the top, and it happens 10 times. So on the very last one, it will change size by 10 and then continue. There's a whole bunch of choices in the look script, so you can change the color effect, you can set the color effect. If you click on these, are also other options inside of here, and you definitely feel free to explore and play with that. So this is the task that we're going to have with this class. Check with your teacher, see if your task is the same. But what you're going to be doing is you're going to use the resize sprites and use repeat loops in order to make sprites move across the stage. So have two different sprites and a new background. The first one of them should get smaller as it moves across the stage. Kind of, for those of you that are a little more artsy, it kind of gives you that look of perspective. And so as it goes off, it should kind of look like it's going in the distance because it's getting smaller and smaller. The other one should kind of have like just fly over. You can have it wait. You can wait until the other one runs back, or you can just have them happen at the same time. That's totally cool too. Add a color change at some point in time to one of the sprites. Have your comments. That's going to be something that we're going to definitely make sure. Have your comments, and it's a major actually part of your grade, is having comments in there. Have a good one.